all, this is our sixth video with a lab on the series of Road to CCNA. In this video, we will be learning about OSPF Multi-Area. Previously, we have learned about OSPF Single Area. Let's see what's the difference between a OSPF Single Area and Multi-Area, and a little explanation about the OSPF Multi-Area ahead of what we have explained before in OSPF Single Area. And let me open the notepad. And let's open it again. Previously I have opened this. Let's see what we have got explained in OSPF Single Area. Here we see little explanation about OSPF features or OSPF on background. OSPF means open shortest path first, not means like open or stands for open shortest path first, and its protocol number is 89, and administrative distance is 110, and it maintains three tables: neighbor table, database table, and routing table. This is how it get communication for one device to one another device, and what we are OSPF using for. If there is any medium-sized enterprise with many routers, it will be very hard to manage with the static routing. You have to mention all the routers with adjacency and non-adjacency routes, and it will be very large of the time. And using OSPF will dynamically learn the network and update the routing tables when any change is made in a network. If there is any bigger network and we have done static routing, if there is any change in network, absolutely you have to get the information from the specific network, and you have to again adjacent, and you have to add that route. It will be very messy, and bigger networks would take a lot of time. And if we implement the OSPF, the routes already have learned, and it will automatically update the routing path if any changes, like any device was down and any device was added and any device need to be modified, like that. And another point, it is used for finding the best routing path that can be used to route the traffic from one network to another network. And if there is a network in area 0 or area 1, and if there is any network from area 89, we have to find the best network between 81, 82, 83, and before all we will be having 87 networks. We have to get the best traffic path, and it will choose the best routers that are up and running, and it will route the traffic from or through the routers that are running in best path. And let's see a little more explanation about OSPF in this multi-area. And the other explanation we can say is OSPF OSPF maintains 5 packets. We have discussed they are hello, DBD, database description, and request packet, update packet, and acknowledge packet. And OSPF also maintains three networks. Maintains three networks. One is point to point, another one is broadcast, broadcast, and another one is multi-point or multicast. Multi-point or multicast. Let's say in point to point, we use serial cable. In broadcast, we use router or switch. In multicast, we use it in ISP side. And let's say what packets are act in each of these networks: P2P, broadcast, and multicast. In P2P, it acts two packets. One is hello and another one is dead packet. And these two packets have a time limit. Hello packet have 10 seconds and dead packet have 40 seconds. And in broadcast, three packets: hello, dead, and the new one adds the wait packet, wait. And in hello, it takes 10 seconds, and in dead packet, it takes 40 seconds, and the wait packet takes 40 seconds. And in multicast, we say hello packet takes 30 seconds, and dead packet takes 120 seconds, and wait packet takes 120 seconds. And the OSPF runs on algorithm SPF, could say Dijkstra's. Dijkstra's algorithm. And as we go through this, and this OSPF is multi-area, and it is run under the link state. In link state, we have network hierarchy. If you have to run the multi-area, the network should be like a hierarchical model, like you have a tree model. And let's say OSPF packet header format. And in a OSPF header packet header format, we have a link header and IP header, OSPF packet types, and link trailer. We see OSPF packet types. In OSPF packet types, we see have a OSPF packet format, version number, type, packet length, and router ID, area ID, checksum, authentication type, and authentication and data. OSPF packet type is version 2. The version number is version 2, IPv4 based, and if it's version 3, it will be IPv6 based. And the type means uh, 5 packets we have discussed: hello, dbd database description, and as we go for, it will be request, update, and acknowledgement. And the next what we have here, packet length. Packet length is varies depending on the OSPF. And router ID. Router ID is different from each routers. One would be 1.1.1.1, the second one will be 2.2. And none of the router have a same router ID. And the area ID 0, 1, 2, 3, and goes on. And a checksum, checksum used for error checking. And authentication type MD5 RSA. And also all the ports will be 0, 0, 1, 2. 0 means null, 1 means plain text, and 2 means MD5. And authentication, the data authentication. And let's see how bidirectional communication works. Bidirectional communication means establishing the OSPF. Let's go here, and here we have router 1, here we have router 2. Let's take, let's connect these two, and here we have a connection from router 1 to router 2. And let's see how the bidirectional communication works. There are 7 states. Which one? The first one is initial state. Initial, sorry, first one is down state. In down state, the routers are in a down position that they aren't communicating each other. The next one is initial state. Initial state where they share the router ID for specific. This is a router 1 and this is a router 2, and this router ID is 192.168.1.1 and this router ID is 198.168.1.2. Let's place the note here: 192.168.1.1, and this one is 192.168.1.2. And in initial state, the router IDs will be shared. The first router ID from the R1, the router ID will be broadcasted saying this is my router ID and I find no one in this network. And they were in a two-way state. uh, the router 2 will be sharing its router ID saying, here we go, I'm in this network and I'm giving you the my router ID. And this is a two-way state. And in two-way state there is also a process called BR and BDR, sorry, DR and BDR. DR stands for designated router, and BDR stands for backup designated router. BR and BDR will be taking place. Let me explain what is BR and BDR. DR nothing but a router there where will be acting as a leader. Let's say we have a topology right here. and we have two networks and connected by one of the middle router. The middle router will be acted as a DR, and the one of the router in this, or these two will be connected adjacently, directly or indirectly. They will be acted as BDR, or one of these router will be act as a BDR. And let's say what is a BDR and DR and BDR in a real life. You have a class group, and in your class group there is a uh, CR class representative and assistant class representative. And if there is any update about your class regarding attendance or classroom student strength, or outside things like a sports or your marks schedule or any update, the students know, and they have to post in a group. But if all students at a single time post the message, it will be very clumsy and one by one, and the each message will be replicated and duplicated. So that if you contact your class representative and post all the messages to the class representative, he will be arranging in order and he will post it in a group. It will be in a specific manner. And what is a BDR, backup designated router? If the designated router is in a down state, the BDR will be acted as a DR, and it will take the position of the DR, and it will uh, get all the information from other routers, and it will filter out the all the messages doesn't mean LSA, link state advertisement. Link state advertisement is nothing but if there is any network from far, there are many networks, and if there is any change in the network, the core router will send the messages to this backup or designated router, and it will give some update to that router and shares the information through this network, so that any update in the network will be resolved. The backup designated router will take place. It will be up when the designated router is down. Same like our class representative. If any leave taken by the class representative, the assistant class representative will be acted as a class representative, and he will get the messages, and he will filter out it and post it in a group. For electing the uh, DR and BDR, we have a election process that will be taking place in a two-way state when the communication is shared, and they will say, I have to be BR, I have to be BDR, so that we have a election process. First of all, the number one thing they will say is higher router ID, and higher priority and higher router ID, and it will go for the higher physical uh, IP address, higher uh, MAC address, like that. And if there is one router having a higher router ID, that will be acted as a DR. Or if the priority matches, then go for router ID. If the router ID isn't present, then go for the highest physical ID, like that. Here we see we have a highest router ID 1.2. So let's take a 1.2. This will be a DR and this will be a PDR. If there is any other network, let's say these are also logical networks, and these three connected to these routers. And if there is any change, if there is any new PC added here, and this will send a link state advertisement message to the DR, and the DR will be sending the reply for resolving the issue to the R2, and the R2 will be resolving the issue. That's how this process takes place. If this router having any fault, and if this is will be a BDR, and BDR will be connecting to R2 and give the link state advertisement reply, update, request update and acknowledgement. This process will be taking place. And right now, let's see our logical let's keep them here and let's move them aside. We need a space for doing our logical topology. Let's take three routers, 1 and 2 and 3. If you ask me how I did this, just after dragging and dropping the device here, just press the control and drag and drop from that router or any device you have taken, it will be replicated again. And let's go for the PCs and devices. One place here and one place here. Let's get connections. Go straight through. It doesn't mean we have to connect the same as a topology. We can connect with any of the interface. It's our choice, no problem. But try to take the correct cable. As we have discussed, the same devices use copper crossover and the different devices use copper straight through. 0 by 0, yes, 0 by 0, 0 by 1. It connects to the 0 by 1. Whatever it is, it's not a problem. But it's okay. Let's first configure IP for the desktop. I'm taking I 192.168.1.2, copy it and paste it for the default gate 1.1. And let's go to PC2. Here we give 2.2 and default gateway 2.1. Let's configure IP address for interfaces in router and enable quantity and interface. Let's get here and first configure the PC1 LAN network IP address 1.1. G0/1. Let's give IP address 0.1.1 and sorry, it's mentioned IP address 255.255.255.252. You can ask me why we have given 4 octets 255.252 when there is a class A IP address, because class A IP address is reserved and we need only limited IP addresses. We take CIDR and it will go for only /30. That would be 2 hosts, and we only having, because we only having a limited host, we can take limited IP address. We need a 2 hosts and we can take one host is this one and one host is this one. And let's give it no short and let's go for route 2 and configure the route 2. No, interface. Let's see what we have in G0/0. 10.0.1.2, sorry, 255.255.255.252, and now short. Here is our connection is up. Let's close this. Let's go for router 3 and configure the IP address. Enable interface J0/1. In router 2 we have forgot to configure the G0/1. Let's configure the G0/1 also, and IP address 10.0.2.1. I told you why we use this class C IP address or class, because we have only limited IP address. Let's go here, IP address 10.0.0.2. Now sure, here we see we have a connection G0/0. To the 1, yeah, to the 1. Here we see all connections are up. Yes, we have all connections are up here. And let's configure the OSPF from the router 1 to last router OSPF router ID 1. Whatever we can take from. Let's see, if you don't know what number to choose here, just say question mark. First get back here and router OSPF and give question mark. Here you see process ID. Process ID ranges from 1 to 65535, so you can give anything. I'm giving 1. And let's configure the network 192.168.1.0. we use wildcard 255 and mention the area 0. Here we see the PC is in area 1. Yes, area 1. Mention area 1. Network 10.0.1.0 and 0.0.0.3, because we have used 252 at the last. Minus with the 255 will be 3, and it's in area 1 as well. And let's go let's change this and w right. Let's go for router 2. First check whether we have got any interface in here. Show IP in OSPF, sorry, show IP OSPF interface brief. Here we see we got 1.1 and 1.110 and 192. And let's go here, router 2, configure the router OSPF process ID 1 and network 10.0.1.1.0 0.0.0.3 area mention 1 because this area traffic coming from this one. I have used a different IP addresses, and we will modify it in topology. Whatever the IP address we can take, it's not a matter. We will modify it. And network 10.0.0.0.003 and area here we get 0. You can ask me why, what this means. It when you configure this network, it automatically gives this connection, and this is a message here we see. And 1.1 network is fully loading to fully. We have got 7 states. We discussed only 3 states here. Down state, initial state, and two-way state. As we go far, we will have exchange, extract, loading, and full. Here loading and full is a final states in a or like building OSPF conversation. The down state, initial state, exchange, and extract already completed. So here we have loading to full state. Let's go. Here we have configured which one, router 2, and let's go for router 3 and see router OSPF 1 and network 2.168.2.0.0.255. Sorry, mention the area 2 and network 10.0.0.2.0 and 0.0.0.3 and area 0. And yes, let's in right and check IP OSPF neighbor. Here we see we got the neighbor 10.0.2.1, and let's check interface IP show IP OSPF interface brief. Here we got, and let's check the ping from router 1 to so PC1 to gateway 192.168.1.1. Here we are getting the reply, and let's check for the router 1 interface for the WAN connection 10.0.1.1. Here we get in reply, and 1.2. Yes, we are getting reply, and go for 2.1. Yes, again, and 2.2. Yeah, and let's go for the router 3 LAN network 2.1 gateway. Yes, 2.2. It lost one packet because to reach the one inside LAN network, it drops one packet to take the auth table. And here we go, we got the reply from that. And let's check from PC2. From PC2, if you give ping command to PC1 directly, it don't lose any packet because it's auth table already built. So let's see 192.168.1.1. Here we see we are having no loss packet here. Directly we are getting reply without losing even a single packet. And this is OSPF multi-area. Let's modify this. Here we have given correct address. Here also we got correct address. And where here we have to modify 1.1 here how much we have given 2, and here 1.2, and here 2.2. This is, and the interface is 0.1. Here we 0/0/1, and here it goes for 0/0, and that's it. And we have completed practice for practical for the OSPF multi-area in a logical way, and we have explained up to let me up to two-way state. Let's also complete the remaining states: extract, exchange, and full to loading. Let me add the note: extract, extract state. In extract state, we get discovering the network routers. The network route doesn't mean another routers, like if we have a router 1 and router 2, and if you configure the OSPF in a two-way state, electric DR/BDR will be completed, and then when you mention this network and the LAN network from router 1 also get to know for the router 2. That's a extracting what are the networks in that state. And exchange state, exchange state. In exchange state, the database description or database will be shared from one router to another router, and the next state will be full state. In full state, the conversation and everything will be implemented, and it is about sorry, it's a loading state. If the communication will be implemented, and uh, it is about to ready to start sharing the data from one router to another router after the communication is implemented. And when the first data packet will be shared, that will be full state. This is all the states we have in a OSPF. Let me drag all these to close to the topology, and you don't have any necessary with this one. Don't get any confusion here. It's all just an explanation. This is our logical topology. This is our this is our physical topology. This is our uh, logical topology. And here we have everything, and I will provide you the packet tracer file and everything in the description soon, and you will get to have this. And this is our OSPF multi-area implementation. I hope you like the video, and if there is any confusion in the video, just mention in the comments and I will try to rectify it, or else you can get the resource from the online. You can resolve it. And thank you for today, and tomorrow we will learn to have the DHCP implementation. And thank you. Let's